Hello, I'm Brian Spears. I'm a freshwater ecologist from the Centre for Ecology and Hydrology in Edinburgh. I wanted to give you a presentation today on some work that we've been doing on emerging products that have been proposed for use in the control of phosphorus in lakes, and to try and stress the point that really none of these products can be considered as silver bullets in lake restoration, but they do have a role in lake restoration, and it's important that we try and put our research into this context. So over the past few years, I've had lots of different types of products sent through to our labs for various forms of testing, and we don't tend to have funding to do a lot of this testing. So some of these products are tested in student projects, some are included in desk studies. But I just wanted to give you a look at some of them so you can see the form of the product we get. These are some solid state products. This one is iron ochre. We have some products that have been engineered to have some specific properties to soak up phosphorus. This one's Phoslock. And then we have others from the built environment, from waste streams from the built environment that are being proposed for use in lake restoration projects. We have some solid state materials that are designed for intercepting phosphorus as its entering systems. And then we have some liquid-based materials that are designed to alter the nutrient concentrations in lakes to result in changes in phytoplankton composition. So these are just some of the examples of the products that have landed on my desk over the last few years, and all of these are new, and not all of them have been comprehensively tested, and certainly few of them have been covered comprehensively in the peer-reviewed literature. And so as more and more of these products come online on the market, it's important that researchers, policymakers, regulators, and industry try and come together to design some sort of standardized means of assessing and validating these products. And really that's what I hope this talk delivers. So we're going to consider mainly phosphorus capping products. So why are P-capping products needed? Well, because our water managers need to control phosphorus across a range of systems and scenarios. And I like to think of these as using this concept of the silver bullet. So when you look for the definition of the silver bullet in Wikipedia, it says in folklore, a bullet cast from silver is often the only weapon that is effective against a werewolf, witch, or other monsters. And the monster that we are considering just now is phosphorus, where phosphorus entering lakes in excess can result in toxic algal blooms and loss in socioeconomic value of lakes. But it's important to know that these products are unlikely to work on all of our monsters that are in our lakes. When you consider a lake, we've got lots of different pressures acting on a lake to degrade it. We can have the non-native invasive species, climate change, nutrient, nitrogen and phosphorus pollution from agriculture, industrial pollution, lots of different monsters, if you like. And so these products are never going to be able to control all of these things, and it's important that we keep that in mind. So geoengineering products are one of many management options available to lake managers. So in the talk today, I want to give you an introduction into some of the existing and emerging products that we're working on. I'll also give you some evidence from a case study where we've tried to look at assessing products using a common framework to try and gain some insights into how they would be used in a lake. And then a synthesis at the end, which is really our first attempt at giving you a framework for product assessment. And the purpose of this is just to put down a line in the sand so that we can start to discuss the best way to develop this, hopefully in the written discussion associated with this presentation. So I welcome your thoughts on this. So one of the issues and one of the reasons that I think that there are so many products hitting the market is that the public and policymakers demand rapid improvements in water quality. So when there's a problem, people want to see it's fixed, and they want to see it's fixed really, really quickly. And these are just some press releases from some examples of these problems across the UK and other examples from the US as well, where people have identified a problem, whether it be pathogens or cyanobacteria, and they've said, right, we really need to fix this quickly. And one of the most obvious ways to fix these problems quickly is to treat the lake with some form of product. And so with regards to phosphorus pollution and cyanobacteria, obviously these P-capping products are one of the first points of call for people who want to see a quick fix in their lake. But it's obviously important to note that these approaches are unlikely to give long-term benefits unless, of course, the source of the pollution to start with is also controlled. So in regards to phosphorus. The load of phosphorus from the catchment needs also to be controlled if phosphorus capping agents are going to have any sort of long-term effectiveness. And so it's the role of the researcher to provide evidence to underpin the use of these products, and this is evidence for water managers and policymakers as well. And so some of the work that we're responsible for at CEH is we provide scientific evidence to underpin the use of products in impacted freshwater lakes, and we look at assessing recovery across multiple scales. We look at assessing ecological and chemical recovery and lag times between those. We look at assessments of the control of multiple pressures to enhance recovery, so not just phosphorus capping agents, but considering the use of these agents in line with many different management measures to achieve many different goals. And then finally, working with small to medium-sized enterprises and regulators to develop new restoration tools and approaches. So working with the suppliers of these products to try and test them and validate them and to assess any potential risk of their use on the environment. And with regards to research facilities, these are CEH's research facilities, but really these facilities are common and can be found in most countries, but we have long-term monitoring sites where we can use our data to give us indications of when it's appropriate to use these sorts of products. Large spatial scale data sets, so looking at thousands of lakes across Europe, for example, to try and identify the proportion of the lakes that need this sort of treatment. And then probably one of the most important ones is experimentation across scales, so actually getting into the lab and into the field to try and test the use of these products. And we'll come back to that later on. So why are P capping products needed, or how do we use them? These are just some examples that I've seen from various conferences and meetings that I've been to. This is one from Finland, where iron was being dosed to try and intercept phosphorus before it entered a treatment wetland. This is one from Scotland, an experiment that we've ran, that we've led, and this is the use of lanthanum and bentonite to control phosphorus release from sediments in lakes. And then we have some other methods that have been proposed at experimental stage, which is the use of some of these products to control phosphorus loads from septic tanks from private sewage treatment works. And so what products are described in the literature? Well, there's relatively few. This table isn't exhaustive, but it gives you a good overview of the types of products that are available and some of the key references within which they've been assessed. So we have different methods, different operational modes of action for these products. We have physical barriers, we have passive capping barriers, we have active capping barriers, and I'm not going to go into a lot of detail about these products, but the operational performance is relatively well described for the products on this slide. But in general, there are lots more products than this, many more coming onto our desks or the researchers' desks every year, and they haven't been well described in the literature. So there are very few market-ready products that have been comprehensively assessed in literature, and there's a need for regulators to outline some standard assessment criteria for product use. So it's important that our water managers know when it is safe to use these products and what products have been through the environmental regulators' assessment criteria and have been judged as being appropriate for use. So let's now look at a case study. And this case study is on Linlithgow Loch, which is a shallow loch in central Scotland, just north of Edinburgh. And it's got a history of cyanobacteria blooms that are driven mainly in the summer by phosphorus loading from the sediment. And we looked at a range of products, some of which came from industrial waste streams, some of which are available to buy on the market. And we tried to construct some common assessment methods to look at the operational performance or operational properties with regards to phosphorus binding across these products. And these are just summary results from a paper that we published recently on this approach. And in table 2, really what we're looking at is the range of phosphorus uptake capacity or phosphorus absorption capacity across these products. Some of which didn't take up any phosphorus, and then others took up relatively large amounts of phosphorus. But we also looked at phosphorus release from these products. So, for example, if you were to apply these products to lakes where phosphorus concentrations were very low to start with, which would obviously be a mistake, but it could happen, then you might expect small amounts of phosphorus to be released from these products into the water. One of the other aspects of the use of these products isn't just the amount of phosphorus it takes up, obviously that has cost implications, but it is the non-target effects on the environment. And so as with the application of alum, the application of some of the products that we considered here had effects on pH of the receiving water. And so it would be important when people were thinking about dosing with these products that the pH effects be considered, and some sort of buffering may be required to use some of these products, but not all of them. And so again, product-specific consideration is required before use here. This table is pretty daunting, but really what it is an elemental description of each of these products, and I'm not going to spend any time going down the data, but each of the products has a very different elemental makeup, as you would expect, and so it's really important to consider whether the elemental composition of these products is actually likely to give you a risk to the environment, so whether there are any harmful components of the product that need to be controlled for, or actually should render it dangerous for use. And that is something, again, that the regulators, environmental regulators, should really be taking the lead, I think, in developing that line of thinking. So because we have lots of different products with lots of different phosphorus uptake capacities, we've got a lot of different dose rates, so you would have to add different masses or different weights of these products to the same lake to have the same effect on phosphorus concentration. The other issue here, which is something that's been raised by various other speakers in this conference, is the fact that excuse me, we're not really confident about how to estimate dose in our lakes. And so what we have here is a graph that shows the dose estimates in Linlithgow Loch for different depths of sediment, so the top 2 centimetres, the top 5 centimetres, 10 and 14 centimetres, and then the different doses that would be required for these various different products that we looked at. And what you can see is that the range in doses is really massive. So if we consider, for example, the most extreme case that we looked at in the paper, the top 14 centimetres, then for one of the products you could be applying 4,000 tonnes to control phosphorus in the top 14 centimetres of sediments. But for others, we could be down at just a couple of hundred. And so the likely implications of those different doses on ecology are something that needs to be tested further and certainly more comprehensively. But just to give you an indication that there's going to be cost implications for these different dose estimates, there's going to be load implications for these different dose estimates, and we really need to get a better handle on how different products can be used in different ways in lake restoration projects. The other issue here is that there's a lack of environmental quality standards for many harmful substances in freshwater sediments. And although the Canadians have developed some standards, and it's likely that under the Water Framework Directive, certainly in the UK, in Scotland, sorry, we will adopt these standards. At present, there's no really clear guidelines on the use of these products in line with ecological quality standards for lake sediments. So that has to be developed further. So just want to bring this all together now and give you some take-home thoughts from me, and hopefully this is really the part of the talk that you'll use in discussing in the discussions afterwards, and the written discussions on the forum. And I do encourage you, please, to get involved in that discussion. It's really important that we get your feedback. I think one of the things that's been apparent to me is that there's lots of different products being proposed for use across lots of different countries, and this tends to be country specific, although there are some common products that are considered internationally. And so I think there's a need to build international networks to exchange knowledge on these products. We've certainly been working with many colleagues across many countries, but more so in the research communities, and less so with regards to policymakers or environmental regulators. So I think there's a need in some of say the big EU projects coming up to try and explore specifically the use and development of these new products at the wider scale. These are just some photographs of some recent visits that we've had, some European projects visiting one of our sites in Loch Leland, and then some visits here. We have Stephen Maberly, one of the session chairs, speaking to water managers in China with regards to an experimental facility which was specifically designed to test the geoengineering products, which is run by Professor Gangpan, another one of the chairs of the conference. And one of the really useful things that's been happening recently, in my opinion, is the development of these websites, which can act as a good hub for some of this information, which is specific to either the assessment of products, the product assessment process, or really some fine detail on how the products work and how you would estimate those, for example. We have another one ourselves looking at UK lake restoration. So I think some of the knowledge in these websites could be combined and used to give more specific guidance on the use of some of these products. The other thing I think we need is a standard framework for validating and assessing these products, and this is my attempt at producing that. And I think these are the three key areas that we need to consider. The first, and they don't stand alone; they're very much linked, and they also need collaboration and good communication between policymakers, environmental regulators, industry and suppliers of these products, and researchers. And the first one I think is technical development, so to comprehensively and accurately document all the previous work on products, to assess the operational performance of the products, to look at things like metal leaching trials in the lab, to look at life cycle analysis, to assess ecological exposure of specific products, and to assess the risks of failing environmental quality standards given the dose requirements of the product. The other area would be validation, so this is looking at whether the products are safe for use in the environment, how effective they are, so trials in mesocosms, looking at the consistency of product composition, excuse me, trying to apply in field trials, looking at application to specific applications, for example, in septic tanks, looking at ecotoxicology, working out an effective dose of the product to make sure that we can't overdose, and then to create procedures of use for water managers to consider. And then the last one is business development or product development, and this is something that I think requires a relationship not only between industry but also researchers and regulators. So identifying all potential applications, looking at market research, looking at IP protection paperwork, making sure the relationships between the partners are clear, identifying an appropriate market value and the market targets, and then agreeing future development plans across partners. So I think actually all of these go together, and it doesn't make sense to me for products to be developed without actually first knowing whether they're likely to be able to be used in the environment. So I think actually it requires some good collaboration across lots of different parties to make sure that this process is successful. And then one of the other things we need is to develop decision support tools for our water managers. And we can do this based on case studies, and we're starting to do this in the UK, where we're gathering knowledge from lots of case studies across lakes in the UK, and we're trying to use that to create these flow diagrams and interactive decision support systems, so managers can go in and say, well, I have a lake, is the problem internal loading, and if so, what products will I use to control internal loading in this specific lake? And then finally, one of the things that I think is most important is to create a series of international research observatories. So these would be when we have field trials that are going ahead, that networks that have been set up can come together and say, okay, we have this field study that's going to be initiated in 2 or 3 years' time. Does anyone want to come on board and measure additional variables in this lake? Because really it's quite expensive to conduct these experiments, and it makes sense to try and pool resources. And also the people who lead some of these experiments really gain from the expertise of collaborators across the world. And some of the problems that are important in other countries may not have been thought of yet in the country where the experiment has been conducted. And so there's lots of added value to gain from these international research observatories. So this is my last slide, just to give you a summary of the presentation so far. Geoengineering products should not be considered as silver bullets. Lakes are complicated systems, and there are lots of pressures acting on them that need to be controlled simultaneously to try and achieve water quality targets. There are many new products entering the market untested, and this is a concern. And hopefully we've set out some of the issues that we found in some of the products that have hit our desk. It's not to say these products won't work, it's just to say that we need to know much more about them before we can use them safely and effectively in our lakes. And so I think there's a need for a standard validation framework, and I've tried to give some of our initial ideas on how we would design that. Hopefully we can have a discussion about that in the forum afterwards. And then finally, I think there's a need for better international networking to demonstrate the use of available products. And again, hopefully some of this can come out in the discussions after the talk. So thank you for taking the time to listen to this, and I look forward to discussing some of your ideas in the forum afterwards. Thank you. Bye-bye.